again, guys, this is Miss Leslie, and I'm coming to you with your video on laws of exponents to help you get through the next objective. Okay, so guys, what I wanted you to do first was to actually look at the PowerPoint, even though it was not the updated one that I sent out, but it will give you a good idea on how to go about solving the problems with the laws of exponents. After you've watched the PowerPoint, I want you to watch this video, and that'll help explain some of the reasons why we have to use the laws that we do. Okay, so guys, if you watch the video, these may be out of order, but you should be able to recognize them from the PowerPoint. Alrighty. So guys, the very first law that I want to talk about is called power of a product. What that means is, if you have the same base, guys, please remember that the base is the big number of an exponent, like the 6 is the base and the power is the little 4. Sometimes we call the power the degree. So you have the big part, which is the base, and the little part, which is called the power or the degree. Okay, this is power of a product. Guys, for each of these exponential laws, you have to make sure that when you're using the laws, the bases are the same, which means the big numbers have to be the same. Okay, when you are multiplying like bases with power of a product, the only thing that you have to do is add your exponents. Okay, so I've got 6 to the 4th times 6. Well, I've got this power right here, but there's no power on this 6. So what should the exponent be? Should be a 1, right? Even though that 6 has no power on it, we understand that it always has a power of 1, because 6 to the first power will give us 6. Okay? Power of product law says when you have the same, you're multiplying and you have the same base, all you have to do is add your exponents. So what this is really saying is 6 to the 4th plus 1, which is 6 to the 5th. That is power of a product law. Okay? The second one that I want to talk about is power of a negative exponent. What I always tell students is, guys, how can you have a number that's being raised to a negative power? Powers are supposed to be positive to make the numbers bigger. So if you ever see a number that's being raised to a negative power, what you need to make sure that you do is turn it into a fraction. The fraction that you'll turn 6 to the negative 5th power into will always have a numerator of 1. No matter what, if you have a negative exponent and it's not in the form of a fraction, use 1 as the numerator, keep your base the same, and turn your power into a positive. Okay? So the answer to 6 to the negative 5th power would be 1 over 6 to the 5th power. Same thing, guys, if your number is already in the form of a fraction. I've got 1 over 3 to the negative 9th power. Well, I'm not going to create a new fraction bar. I'm just going to use the fraction bar that they've already given us, which means I'll take this 3 to the negative 9th power, and instead of creating a new fraction bar, I'll use this one and bring this up to the top. Okay? So what you have in the top is 1 times 3, base stays the same, and instead of having negative 9, it'll be positive 9. So what's left in the denominator? A 1. And 1 times 3 to the 9th would be 3 to the 9th over 1. And 3 to the 9th divided by 1 would be 3 to the 9th. So guys, please make sure that you remember that if it's not already a fraction, turn it into a fraction. If it's got a fraction already, use the fraction bar that they give you and just flip it over. Okay? Make sure you keep your base the same and make your power a positive. All right, guys, the third law is power of 0. In the PowerPoint, I said any number, any variable, any term that is raised to the 0 power will equal 1. So look at this huge number I've got here. But look, it's raised to the 0 power. So I automatically know that the answer is 1. You can do this with any number that's raised to the 0 power, except for 0. 0 to the 0 power has no value. It is unsolvable. So please don't let them try to fool you if you see that in your lessons. Any number to the 0 power is 1 except for 0. Okay? Here's another example, guys, of an exponential law. This is power of a quotient. You can tell that it's a quotient because you can tell that we're dividing like bases. Both of these bases have a base of 8, but we're dividing. It's 8 to the third divided by 8 to the negative fifth. Guys, there's two ways to go about solving this because we just talked about how you could take 8 to the negative fifth power and move it to the numerator. But I want to also show you that you can use your power of a quotient law to make it work too. So this is the thing with power of a quotient. When you are dividing like bases, all you have to do is subtract your exponents. So what I'm really saying is you'll take 8 to the third and subtract negative 5. And if you know your integer rules, you recognize this as a double negative that will change to a positive. And 3 plus 5 is 8, so it's really 8 to the 8th power. Guys, don't forget you could have also taken 8 to the negative 5th power and moved it up here, and it would have become positive. And you still would have added the powers together and gotten 8 to the 8th power. Okay? The last exponential law is power of a power. That is when you have a tiny exponent being raised to an exponent. Okay? Guys, if you have more than one term or more than one number or variable or anything inside of the parentheses, make sure that you're raising the 3 that's on the outside to each term that's on the inside of the parentheses. Okay? But power of a power just says when you have a power being raised to another power, you just have to multiply those exponents together. So what this is really saying is 9 to the 2 times 3, which would be 9 to the 6th power. Okay? So guys, I've taken you through power of a product, power of a negative exponent, power of 0, power of a quotient, and power of a power. I want you guys to understand that sometimes they will combine exponential laws together, and there are several ways to go about solving them. So I want to do a couple of them with you to make sure that you're understanding which law would apply and which one would be best to use. You guys know that that's not the only way, as we've seen in previous problems, but I want to make sure that we're doing some combination ones in case you have questions. Okay, so guys, right here, 2 to the 5th to the 3rd divided by 2 to the negative 2nd. First thing I want to do is take care of my exponents. This is power of a power. You see that 5 is being raised to the 3rd power. So what I need to do is take 2 to the 5th and multiply it times 3. And that'll give me 2 to the 15th over 2 to the negative 2nd. Now, there are two ways that we can handle this. You can either use your power of a negative exponent law, or you can use power of a quotient law. I'm going to choose to use power of a quotient law, which means if you're dividing like bases, you subtract the exponents. So what you're going to do is say 2 to the 15th minus negative 2. Notice, guys, I put both of my signs because I have to subtract the exponents. I'm subtracting, and that 2 is negative. So again, here's your double negative rule that we change into 2 positives, and 15 plus 2 will be 2 to the 17th power. Guys, please be careful with your signs, okay? Let's do another one. Negative 3 to the 2nd divided by 3 to the negative 2nd. Now, guys, I know that you think that you want to simplify this because the bases are the same, but these bases aren't the same, are they? This is a negative 3, and this is a positive 3. Guys, please remember that you can only use your exponential laws when the bases are the same. Okay? Now, one thing that we could do is go on and simplify this, negative 3 to the 2nd power. But something that you would need to take care of first is this 3 to the negative 2nd power. Remember, we already have a fraction bar that we can use. So I'm going to keep my 3 to the negative 3 to the 2nd power and multiply it by 3 to the 2nd power. Guys, notice that I took the 3 to the negative 2nd power and moved it up to the numerator. Okay? What will be left in the denominator? Just 1, right? Negative 3 to the 2nd power would be negative 9, and 3 to the 2nd power would be positive 9 over 1, which would be negative 81 in the end. Okay? Let's look at this one, 5 to the 0 divided by 6. Guys, remember, any number that's raised to the 0 power, this is power of 0, any number raised to the 0 power is 1. And what's left in the denominator? 1/6. Can't simplify that any further. So guys, I just wanted to show you a couple of problems where they're going to be combining your exponential laws together to make sure you have a good understanding that yes, they can do that, and what you need to do is just decide which law is being applied, so you'll know how to go about solving it. If you guys have any questions, make sure that you're emailing me, texting me, inboxing me through Odyssey Where. All right guys, take care.